In this video, we're just going to review the basic rules of differentiation that were covered in our class investigation. The first one is called the constant rule, and it states that whenever we take the derivative of any function that's simply a constant, we will always just get 0. And that, of course, is because the rate of change on a constant graph, which would just look like this, there is no change, right? It's just staying flat, and thus the slope or rate of change is always 0. The second rule is the constant multiple rule. And this rule states that if we take the derivative of some function with a constant out front, which often looks like a coefficient to us, then it's simply going to result in that constant multiplied by the derivative of that function. So similarly as what we did with limits, you can kind of pull those coefficients out front and then do the actual derivative like you would normally. The third rule is the sum rule. Sometimes we call it the sum and difference rule, and it's pretty intuitive. And it states that if you're trying to take the derivative of some sort of combination of functions, either being added or subtracted, that it'll simply result in the addition and subtraction of their derivatives. So again, pretty intuitive. We like this one. The fourth rule we talked about is the big one. It's like that one rule that for some reason years later people remember this one thing about calculus, and it simply states that if you're taking the derivative of some polynomial, usually is how we think of them, but something raised to a power that's a constant, then that power simply comes down front and multiplies by x to the n, and we lose a degree. Now, one thing I do want to caution you about, this rule only applies, again, when n is some type of constant, has to be a regular number, and when the base is just a single variable such as x. So for instance, if you had something that looked like this, we would not be doing the power rule for that. Or if you had something that looked like this, we would also not be doing the power rule for that. So it has to be a pretty simple polynomial type function for it to work. Now, one thing that is interesting, if we go back to our first rule, the constant rule kind of falls into this, because if you have a constant in reality, like if we had the function f of x equals 6, right, that's really 6x to the 0, right, because you don't see the variable there. So if we do the power rule here, when we take the derivative, we could pull that 6 out front, constant multiple rule, right, and then it would be 0 coming down front times x to the 0 minus 1. But none of this really matters at this point because we have this 0 right here multiplying everything, which means that we end up with a 0 overall. So kind of cool how that works. Okay, so let's do some examples. So for each of these, we're going to be answering the question of what the derivative is, or to find dy dx. So for our first one, we're going to look at the function y equals 1 over x to the 4. And a lot of times with these, using the power rule, we need to rewrite the function first. So for instance, this one would simply become y equals, and then I need to get rid of the fraction here, so that's going to be x to the negative 4. And now I'm ready to actually find the derivative. So dy dx would equal, bringing that exponent down front, so negative 4 times x to the negative 4 minus 1, and now we'll clean it up. This will simply become negative 4x to the negative 5, and you are welcome to leave it like this. If you're doing homework or you're just answering a free response question, you want to simplify as little as possible because that's when we tend to make mistakes. But if it's a multiple choice question, a lot of times they'll simplify it further and get rid of the negative exponent part by putting it back as a fraction. So in that case, it might appear instead in this form. Both are fine for me. Again, if it's a free response question, I'm fine if you just leave it without simplifying it back. but on a multiple choice question, they may go ahead and put it in this form, so you need to be familiar with both. Okay, so for the next one, y equals x to the 5th over 2 plus square root x. And again, I'm going to kind of rewrite this where I can clearly see the exponents. Common mistake, right? If the number's in the denominator, this guy's just x to the 5th times some sort of coefficient. The one we did above, it had our variable in the denominator, which is how we ended up with a negative exponent here. Okay, so you've got to make sure you can differentiate between the two scenarios. So this one would turn into 1/2 times x to the 5th, and then any rational exponents will be used for the root symbol. So this would just be x to the 1/2. But we do have to write it in this form before we can actually take the derivative. Okay, so for the first part, we're going to use that constant multiple rule here because the 1/2 is out front. So I'm going to leave it out front. And now derive the actual x to the 5th. So for that one, the 5 would come down front and multiply by x to the 5 minus 1. Okay, and now for the 1/2, x to the 1/2, the 1/2 would come down front and multiply by x to the 1/2 minus 1. Okay, and you don't have to write this minus 1 step. Once you get good with these, you can pretty much just go straight for that next answer. Okay, so 1/2 times 5 will give me 5 over 2. That becomes x to the 4th. And then this becomes 1/2 x to the negative 1/2. So again, you can leave it in this form. That's what I do when I do these problems. But again, on multiple choice, if you were to simplify this back, it might look like the following. 5x to the 4th over 2 plus 1 over 2 square root x. Okay, so for our last example, we're going to put all of these things together. Okay, so y equals the square root of x plus 3 over x plus x to the 4th over 5 plus 6 to the 7. So again, let's rewrite it first before we even try to derive anything. That's going to be x to the 1/2. This is going to have a negative exponent because it's coming out of the denominator. This just has a fraction coefficient because it's in the numerator, so it's a positive x to the 4. And then 6 to the 7 is just a number, so we're going to be careful with that in a second. Sometimes they try to make it look like it's something you should do more with. Okay, so 1/2 will come down front, and then I'm going to start doing the minus 1 mentally. So 1/2 minus 1 will give me negative 1/2. Here, it's going to be this negative 1 coming down front and multiplying by the 3. So we're going to have a 3 times negative 1. And then x to the negative 1 minus 1, which will become negative 2. Okay, plus 1/5 times 4 comes down front, x to the 4 minus 1, or 3. And then 6 to the 7, that's just a number, right? It's a constant. So when we derive it, it'll simply become 0. Now we can actually clean everything up. So 1/2 x to the negative 1/2. Ooh, cannot write. This would become minus 3x to the negative 2. This would become 4/5 x cubed. And then that 0 would be gone. So this is, this is one of the forms you could leave it in, or you could clean it up even one step further from there. Okay, which if you did that would look something like this. So that's our basic differentiation rules. Up next is the product rule, followed by the quotient rule.